Okay, there's a couple of ways we can answer questions based on particles moving in electric fields. The first way we've seen is if we have, say, an electron and it's in a magnetic or an electric field, sorry, say between two plates that have 10 volts across them. This one's the positive plate, this one's the negative plate. That electric field is going to accelerate it in this direction. And what we can do is we can use our conservation of energy to do this type of question. So we can just say that the kind of electrical energy that's stored at the start is the charge times the voltage, and then at the bottom that will all get converted into kinetic energy. And we can do our questions that way. Now that works quite well and quite easily until we start doing things like having a plate with an electric, two plates with an electric field between them. But if then the electron enters it and is moving with a sideways velocity, it's going to accelerate down this way, which means there'll be a force and acceleration that way, and its path is going to be more something like that. We then can't really use those equations. We have to use the equations you would have used for projectiles in year 13. In fact, it's just a projectiles question, but instead of a gravitational field, it's a charged particle in an electric field. You just have to do a little bit more work at the start, because we know in a gravitational field on Earth, the acceleration is going to be 9.81 towards the ground. We have to do a little work with electric fields to work out the force and therefore the acceleration on the particle, and then we just apply the same principles as before. So we're going to work our way through quite a long question. I might break it down into a few videos that will show you the steps you need to go through to solve that. Okay.